Good morning, good afternoon. Uh, Today, this is AI Foundations, and we're starting Module 6, Responsible AI with Benjamin Cox. So Benjamin is going to go through two modules on Responsible AI to kind of give folks an introduction into some of the basics around this topic. So with that, I'm going to hand it over to Ben. Ben?
Hey, thank you, Raphael. Can you hear me okay?
Yep, I can hear you fine.
Awesome. All right, so my name is Ben, as Raphael said. I'm Director of Product Marketing here at H2O. I focus on a lot of the academic, quantitative, thought leadership research around responsibility, explainability, interpretability in the AI machine learning space. And we'll kind of get into what more of that means. But with that, let me kind of kick this off, right? So why are we here? This lesson is called Responsible AI in the Enterprise. And there's two flavors of this talk. There's one that's kind of technical, which is sort of where H2O started, but there's one that's sort of more organizational, theoretical, and high level. And that's what we're going to kind of do today. So I'd like to start off with this quote. I think there's a lot of conversation in the AI ML space, especially when newspapers cover it and things like that, because it's a very easy technology topic to kind of paint in a light of doom and gloom. This big, automation overhaul. There's no jobs left. Terminator, Skynet, all the whole nine yards. But I do think that this Stephen Hawking quote is pretty relevant, right? Like, success in creating AI would be the biggest event in human history. Unfortunately, it might also be the last unless we learn how to avoid the risks, right? I think that what's important to note is whether or not we're talking about something like the end of the world, you need to consider, once you start to talk about algorithmic decision-making for your company, for your business, for your personal efforts and pursuits, what you're doing can have a very big impact, right? When we start, so a big example that comes up a lot is lending. And it's, back in the day, if somebody who was generating loans for somebody to get a house and they had discriminatory practices, they could be held accountable, right? They could, we could go back and look at the data and say, hey, this person who came in the door should have gotten a loan and you just didn't give it to them. What gives? But the problem is because we have so much data and so many decisions and predictions that need to be made, one thing that comes up is accountability. And we need to be able to be better with responsible AI about how are we making these decisions, who's overseeing them, whose feet are held to the fire if something should go wrong. So it's really critical that we get this right, because there's been this theme in technology, move fast and break things. And we've seen a lot of the scenarios where moving fast with AI broke things, right? I think most of the people on this call at least have some sort of interest or passion or pursuit in AI and want to get better. So I'm sure that you've seen at least one of these, right? Microsoft opened up its Twitter NLP bot, and immediately, because of a data poisoning exercise by all of the random people on Twitter, this bot became completely useless in the function that it wanted to have and became a very offensive bot, right? I think one of the examples that came up early on, before we really knew how to identify these AI incidents or AI field cases, was the Target case, right? The story of that one goes, a father started getting a lot of promotions for things at Target that had to do with pregnancy. And his daughter actually did not know she was pregnant yet. She just had a bunch of searches on Target for various things that are often highly correlated with somebody who is in their pregnancy, right? I know one of the ones that I encountered in my first job was in high frequency trading was, this algorithm that flash crashed the British pound. And I know that one of my competitors early on in my career had a latent trading algorithm that had kind of been like a remnant or artifact code that they hadn't deleted out of their base. And out of nowhere, with some new rule that happened, it interacted weirdly with an old latent line of code. And that company lost $430 million in 30 minutes, right? The impacts of getting this wrong are extremely severe. It can be, right? Not always. And the cases where it doesn't come top of mind are arguably much worse, right? Because if we don't get these big headlines where we see that this AI incident happened, how do we know that it's going on, right? So it requires, like in this instance of racial bias in medical algorithms, it requires deep researchers to kind of go into the hood and poke around and see, I have a suspicion that something might be going on here. Like now I need to go test it. So it's tough. And I think, one of the good companies in this space or organizations is called Partnership on AI. And, if you're aware of an AI incident, as they call it, like a lot of these examples, like these fail cases, you're able to report it and put it in this database. And I think they said as of late, they have over 1,200 logged AI incidents, right? So there's a lot of cases where these go wrong. And now more than ever, over the last 6 months, there has been an extremely fast and quiet push towards regulating companies deploying AI. And that's something that we want to monitor as much as possible. Like, and one of the things that we do here is we definitely focus on what are the current regulations that are coming up, what regulatory authorities are overlooking this, because it matters tremendously. And I think what companies fail to acknowledge is the fact that if you're deploying like AI in any sense of the word, whether it's, a logistic regression for, predicting, what we're going to price a home at, and some regulatory authority says like, okay, well, now you need to get in line with SR 11.7 model risk management regs. How much will that cost your company? For a lot of companies, that's a really big cost that they're about to incur, and they're just not prepared for it. So what we're trying to do is get people prepared for it and get companies to understand how they can start making the pivot into a responsible AI organization earlier rather than later. So it's not a responsive or retroactive kind of like fitting into a regulatory framework, because we have a lot of the best practices now that we're aware of, and we're just going to try to stay cognizant of it and encourage those. So let's go to the next one. Yeah, and this one, AI Now does a really good symposium, and they probably have a new version of this, but this is one of my favorite slides, right? I think that one of the things that we struggle with in artificial intelligence, well, let me actually take a step back and say this lecture might be a little different from the other ones. This lecture will be different because a lot of the other lectures we talk about, okay, how do you AI? How do you build things? How do you kind of set up the infrastructure? And while this lecture has all of those, this lecture also has to talk about some of the like social, political, ethical issues that surround this technology, because you can't separate the two. As much as I would like to separate the two and take away all of these types of topics, it can't be, because in the public eye, it's bundled, right? So this image is good because it shows over one calendar year how many AI incidents or technology incidents occurred. And it's really important, right? Because like AI starts with data. So anything that goes wrong with data will also perpetuate through to a model. If you take nothing else away from this lecture, take away that, right? Garbage in, garbage out. It's an overused saying, but it's really, really true. So when we see things like, GDPR officially implemented, that's really good, because one of their best things is about data quality, data lineage, data accuracy, and all of these data protocols to like ensure that the data supply chain before it even lands in a predictive model is stable, right? So all of these various things, I won't get into all of these, but there's a few ones that I might want to call out. Cambridge Analytica was really big, right? Like I think data science had been this really kind of shiny new thing that everyone was so optimistic about. The use cases were so positive, but then it sort of got into this world of, if you wanted to make a lot of noise, how could you do it? And could you use data science to do it? And the answer was yes. And just at what fee, right? And then you see situations like an ICE modified risk assessment with automatically recommends detention, or IBM, New York Police Department. A lot of these things aren't good for the public trust of AI, right? I think people already have historically been on edge about robots taking my job. What does the robotic economy look like? Can I be replaced by an algorithm? What does that mean for me? Is the economy leaving me behind? all of those considerations are super valid. And so when you add in okay, now what are people using algorithms to do that might be evil or feel like they're evil, matter a lot. So this is just one calendar year and all of the various like technology trust incidents that occurred. And it's only ramped up since, right? Like we have not gotten better since 2018. So kind of going forward. Yeah. So I think the way that H2O approached this was from a world of explainability, right? And I think that's 2 years ago, that was the latest and greatest. To think about explainability, which we're going to go into a little more, H2O had built out a platform with a bunch of phenomenal technology tools for unpacking, explaining, analyzing, and tinkering with models to come up with like, what was the root cause for a decision? How important were various features? And those were really relevant, and those are really relevant in financial services. So H2O kind of landed in this space as a result of wanting to give our customers the best tools available for, passing regulatory audits and regulatory review and oversight in financial services. But we kind of learned that being able to unpack a model after the fact is only just one piece of this, right? That's not enough. Like, as I mentioned with GDPR, garbage in, garbage out. So there's this whole world of everything from data creation or even data sourcing to post hoc model explanation and everything in between that really kind of defines, are you being responsible with your artificial intelligence? And, we kind of landed about it this way. I think a lot of other companies landed about it the opposite way, where one of the first problems they tried to solve were, what is an ethical AI, right? We did not do that. We did not staff PhD ethicists. We don't have them. But I do know that we approached it from a statistical and technology perspective first, and then started kind of slowly broadening that scope of what are the human considerations, what are the technology considerations, what are the process considerations. And that's kind of what I'm going to talk about today, because I think that's really important, right? Like, I think that if you're a company, big or small, and you're talking about responsibility in deploying artificial intelligence, or you're about to deploy AI for the first time, you want to do it in a way that's not going to create a whole lot of technical debt. And you want to do it in a way that you believe like you've built the team around it correctly. And there's not enough conversation there. That's like a personal opinion of mine, and I think Ishuo agrees. Like, there's not enough conversation going on about how to build out responsible AI teams. Like, we can start and say disparate impact, Lime, SHAP values, and a bunch of, and that'll be the next section where I talk about the statistical methodologies that we believe are the latest and greatest, and the industry kind of backs us on. But what I want to talk about today is, as a business owner, operator, leader, executive, who's not a data scientist and who's not going to be like, tinkering with features within a model, what can you do, right? And I think that's the really important part. Being a statistical audit function is great, and it's super, super important. Don't let me discount that at all. But there hasn't been enough conversation of what does a responsible machine learning organization look like. So today, we have a lot of different pieces in the works about how this looks, books, papers, research, and stuff like that. But I'm going to propose some of it early, and I'm going to show you what, if you ask us what that looks like and what you should aim to be. And obviously do it with the caveat of some companies are smaller. You'll have to pick a more lean version of this. Some companies are too small to pay a chief model risk officer, and we understand that. And we can provide more color offline about like what you might do in place of that. But I'll show you what we've proposed and published as a responsible machine learning workflow. And then I'll show you how that fits into the process workflow of organizations. And then I'll show you how that fits into an organizational structure that can be expected in a company who's going to be deploying predictive models at scale. Cool. So considerations. Let's get into it. With that, I kind of want to propose our biggest picture of what responsible AI should look like, right? So what you'll hear often is is a term called FATE, or FAT, which typically stands for fairness, accountability, transparency, and ethics, which will be what a lot of folks kind of define as, you know, the core features in responsibility in machine learning. But frankly, I disagree. I think that accountability, transparency, fairness, and ethics say a lot, but they don't necessarily provide a tactical way to kind of go do that. Like, I think if you go and you look up, you know, responsibility, fairness, and that stuff, there's a lot of good kind of guiding principles. But if you are a company, it doesn't give you directions on how to do it. So that's what we want to try to do, is be slightly more actionable here. Like, we want this conversation today and, you know, later this week to basically give you the playbook to how you can start doing things better. Because I think there's tons of thought leaders in this space who put together a ton of research or propose a lot of great principles. But I think it's really important to understand, like, how you would even do it. All right. So with that, I'm going to kind of talk about the 6 core tenets that we look at, right? Like explainable AI, which is I brought up earlier, where we sort of started. And it's the idea of the focus on the ability to analyze an ML model after it's been done, you know, or been developed. So, right. So a lot of you should be familiar with this, right? This is the kind of, you know, feature importance, surrogate decision trees, partial dependency plots, you know, KS test, like all of the sort of kind of classic model validation, model testing tools that you might use to take a model that made a bunch of predictions, and then you to kind of think about how good was this model, and where did it kind of break, you know, disparate impact analysis, sensitivity analysis. Like, it's all of these things post hoc that you can think about. How is this model performing, right? And then another term that often gets confused, and let me actually make a caveat here and say that these are our proposed definitions. These aren't final. These aren't in the dictionary. These are things as we see them. And if folks have any, you know, counter proposals, disagreements, critiques, commentary, please bring it up with us. Like, I would love to have this discussion, and largely, like, the core thing that I want to get across today as well too is there's no finish line for this. There's no race to get your definition in a dictionary somewhere. We're all trying to progress in this space to increase transparency for everyone, right? So if something here that you feel that, like, our research team is off base on, we'd love to have that discussion, because there's no finish line for responsible AI. It's only how can we continue to get better in understanding, in building stable models, in you know, building interpretable models. We're just trying to get, you know, put one foot in front of the other and continue to get better as you know, a subset of AI, right? So would love to open this up to any debate or questions, and have those, because a lot of people see certain things differently, and we totally respect that. Interpretable machine learning. This is one that's super important, right? Transparent model architectures and increasing how intuitive and understandable ML models can be. So there's 2 pieces to that. Transparent model architectures, right? One of the things that I bring up a lot is that, you know, when deep learning came around, it was this sort of silver bullet, and everybody wanted to kind of race to how they can deploy deep learning, right? But by nature, it's not very transparent. You know what is very transparent is a GLM, or logistic regression. Now, what we want to do, and what practitioners of data science should do, is find that stability versus signal trade-off, or simplicity versus signal trade-off, right? So the idea was that, you know, a logistic regression, or, you know, a binary classifier was super simple and pretty accurate, but a deep learning model was was not transparent, very complex, and very accurate. The good news is, based on, you know, some research that we've helped publish recently around explainable neural networks, if you're dealing with tabular data, the trade-off between simplicity or accuracy, or complexity and accuracy, doesn't have to be sacrificed anymore, right? Because Now we have, for tabular data, transparent neural network architectures that we can actually explain much better than we did in the past. But I would still push folks deploying models, if you can get a reasonable amount of similar signal or accuracy with a simpler model, do it. Because what happens, and what happened in data science, is we learned that there was just a big push towards overfitting, right? And it might not appear in like a heavily bootstrapped or bagged sample, but once you get to live out of sample data, oftentimes you find out your model was very overfit. And what we also found out with coronavirus and COVID was that a lot of the models in production at various companies, so we'd use the term break, and I don't want to say break because it's not necessarily true. What it was is we found out a lot of models that were in production for various things did not prepare for an anomaly situation like COVID. And I'm not saying that they should, but many models should have predicted at least some kind of anomaly situation. And you typically won't do that if you over complex your model. If you go too deep into the rabbit hole with some, 50 hidden layer neural network, you're just not going to prepare for kind of anomalous situations the way that you should be. Right? So that's one piece, transparent model architectures. Essentially, if you can get with a shallow random forest very close to a big ensemble method, you might want to go with that. You probably should. Increasing how intuitive and understandable ML models can be. This is important, right? What's been really cool is seeing new model methods come out, right? Like boosted trees. So tree-based methods with a boosting function that are more transparent than, nets, right? Or explainable neural networks, an uptick on neural networks, but actually have explainability components. Or lately, another thing that we had into H2O was, GA2Ms, which are essentially, generative adversarial models with an interaction term, which allow a lot more transparency into these kind of adversarial networks. So I think that as practitioners get better, we're also getting better at creating transparent model types, which is great. That's what we want to do. Like it was cool when we started and we couldn't tell why like the bots were doing what they were doing, but that's just not practice for business operators, right? Like you just can't be a company that deploys a material, like a predictive model that's material to your business and not know why it's making those decisions. Okay, the next one is the hot button topic, ethical AI. So what I want to do is propose that as practitioners of data science, one thing that we should really aim for is not allowing models to perpetuate historical human bias that might have seeped into the data set, right? I used the example earlier of some loan desk character who was biased in the way that he made that decision about that loan. But now that existence is in the data set, right? That human bias is now in the data set that we're training on to build, a loan decisioning or credit decisioning model. H2O recently released a paper alongside a financial institution and a economic consulting firm on discrimination as it pertains to fair lending, specifically around machine learning, how it can be used to help it, how it can be used to not perpetuate it. And I think it's really important. That being said, I also want to caveat this with, I am not an ethicist. I think you can go on YouTube and find various presentations that say 23 definitions of fairness or X amount of definitions of ethics. And it's a very complex subject. I think we boil it down into much more simple terms than it can be. But generally, in a simple fashion, what we should aim for is make sure that, people are, ECOA, Equal Credit Opportunity Act, says people cannot be discriminated based on their ethnicity, their gender, their age, their marital status, their sexual orientation. We should aim to abide by those principles, right? These features should not be used to make predictions. These features should not be weighted in your predictive model. We shouldn't find a disparate impact between, one ethnicity and another, right? That just full stop, right? I think it's simple to say In practice, it gets more complicated because also remember these models are smart. So take an example where we've had a historically biased data set and the model is trying to perpetuate that bias. So let's say we have a model that's very biased against single people in the marital status example, right? But we say, okay, now let's just take marital status out. Let's just toss it out. And this is an example that has happened in other flavors. Let's take marital status out, run the model again. The thing is that models are smart, right? Like models can find interactions of features that just recreate marital status, right? Are they living in a 1-bedroom apartment? Is their income at this level? Do they file single or joint? You know, boom. That you can probably in those those three variables create a feature that accounts for 99% of predictiveness or R squared in that marital status feature, right? Understand that if your model has seen the data with that feature that it shouldn't, it can very quickly reverse engineer it. So how do you start to work back and keep taking steps backwards to strip that bias out and just strip that intelligence layer out that you don't want? Okay, secure AI. This probably might be the most important, but gets talked about the least. Because AI and ML are like statistical models, that at its core, the technology has not been treated with the same sort of like cyber security and privacy and defense considerations that it needs to. It should be handled with more, and it's actually apparently handled with less. So models can be hacked, right? Like if we think about the example that I gave earlier of Microsoft Tay, where the Twitter bot went public and Twitter immediately corrupted it. That's just a classic data poisoning example, right? Now imagine if you're an online retailer and somebody sends a bot to come poison what they think like a typical customer looks like. It's the exact same thing, right? People can force data into your model, and you need to be aware of that. So there's plenty of other examples of this, and I'm not going to get into them because I'm not the expert on it. But data poisoning is a very tangible one. And then there's also another one that I forget what it's called, but it's essentially, pinging certain models and getting decisions and finding out what the thresholds are. Like, what are the slight, adjustments you might need to make to get moved from a no prediction to a yes prediction? And then you can kind of back solve from there and see what kind of feature weightings, gets through certain predictions or classifiers, right? So those are just two examples, and I'm happy to talk about it more offline. There's a ton of literature on this, especially from our own Patrick Hall, and it's tremendously important. And once it becomes like the top of conversation, it won't stop. So just be aware, right? Human-centered ML. This is probably my favorite. We do a really bad job of as practitioners, because we like how great the technology is, but also as industry commentators, because the idea of an office of just robots and algorithms is just like so salacious and sells so well in articles. But the reality of AI for a lot of people is just an augmentation function, right? A lot of people working in factories are just like equipped with predictive maintenance algos. Or, analysts on a bank's credit desk are just equipped with really big data dashboards that have AI engines behind them and tell you what kind of like credit decision should be made, right? Like customer call center people are often just equipped with like a live real-time monitor saying, what angle should they take the call in? Are they taking too aggressive of a tone, right? A lot of the best AI cases right now in industry are just augmentation, right? They're not trying to delete a bunch of jobs. They're just trying to make people better at their jobs, right? And I think that's really cool. Like, I think I'm putting an article about it out next week, and I think it matters. Like, I think we talk about the economics of AI all wrong. We talk about it as in this like delete your entire workforce with one predictive model lens, and it's just tremendously toxic, right? It's not the way that we should do it. So I'm happy to discuss this more. I think this is really important. But really, human-centered ML for us is just user interactions with AI ML systems, right? That example I gave to you before about the trading desk that algorithmically lost $430 million in 30 minutes, that was a fully systematic system, right? Like that would not have happened if there was a human in the loop with a kill switch, right? Because it went for 30 minutes. Right? So, and that's one of the things you need to think about too with your AI machines are what are the velocity of predictions that it's making? Is it thousands per second? Is it 10 per day? It matters a lot. And it will dramatically dictate how much you invest in responsible AI and really double down on this, right? So the last one that I don't have listed here because it's sort of a no-brainer is compliance. You know, it's hard. I don't like to be this guy really, but if you are deploying I think everyone should go look at SR 11.7, Reg B, ECOA, FTC's latest guidance, FINRA's latest guidance, White House OMB's latest guidance, because we have seen it in industry where companies have now been regulated that are not financial services firms, and they've been asked to tell regulators why predictions are being made the way that they are, and they can't do it, and they fail these regulations, and they get fined millions of dollars. Right? Don't be that company. When you start adopting AI now, you can do it from a place of responsibility. Right? Like you're able to do responsible AI great now. And you can start it, and it's lower cost. It's not going to bankrupt you. You will need to take some kind of moderated versions at times, like not having a chief model risk officer. But I'll show you. I'll get into this. So this is kind of our core themes. I would love to talk more to folks about this. This is something we've been talking about heavily, and it's high level, but it's important. All right. So AI risk iceberg, right? This isn't an overtly too deep slide. I think a lot of customers and clients that I talk to, they think that their barrier to AI is twofold, or like their risk barrier is twofold. And we don't have the talent to ensure what's going on, or we don't really want to take on the PR regulatory risk. But that's actually not the end of the story, right? Like, how are you going to move into automating certain tasks? What does that mean for your organization? How do you keep your employees in good positions that are still profit driving? What is the ethics and bias considerations that we've discussed? What kind of new risk are you taking on? What kind of risk are you mitigating? What does this new like risk profile look like to your company? Obviously, like the ML cyber example, like, do you understand how prone you are to, data poisoning, or adversarial model hacking, and then technical debt, right? Like, do you know how much debt you're bringing in from an organizational and a technical perspective? And these are just kind of get glossed over, right? I think these are a lot of the heady human considerations that we don't talk about. And I think these get really, really important, because most companies adopting AI are pretty mature. Like, they're pretty big companies, or they're young tech companies, and recruiting is expensive. You pay a lot to get talent because what you're doing is specialized, right? So the answer can't simply be, put a predictive model into deployment and fire a whole team, right? That's just not an economic way to scale into this technology from a risk perspective, from a value perspective, from an organizational perspective. It's just not the way to go. All right. So one thing that comes up a lot is there's this idea that business leaders and data scientists want different things, right? Like, data scientists aim to trust their models and understand their models more, and business leaders only care about risk. This is this wall that has appeared to exist. But the reality is, what's ironic is that these are the same thing, right? The more you trust and understand your model, the more you understand your risk. The more you understand your risk, the more you can mitigate it, right? It's that simple. And what's been hard about data science is a lot of times it's so complex. There's this break off between business leadership and data science teams. And there is a real something to be said for how complex it gets trying to explain something like SHAP values or K-Lime at a level that a layman could understand. And that's something that just we struggle with in the industry at all. Like, how can we simplify things to the point where it still conveys the message and the importance in the way that it does without convoluting it or losing people in the process? And that's like a balancing act that we will continue to struggle with. But explainable AI aims to kind of simplify this, right? So I'm going to kind of burn through a couple of these quickly. Like, one of the things that we see a lot in terms of organizationals about to adopt AI, one is data and analytics, DNA, as a vertical, and then sometimes as a horizontal. Both of these are actually incorrect. Well, not incorrect, but both of these come with their own problems. Like what happens in the DNA as a vertical is you end up having this one silo that's responsible for all of the kind of analytics and machine learning data science workflow. And one, they're just always underwater. And two, they're constantly reporting out to 30 different units. And there's never really any like coherent thread of what's going on, and just big silo and transparency effects, right? But, model two, where there's an individual DNA within each traditional line of business or LOB, is you have this silo effect where a lot of data and analytics groups are spending time building the same tool because likely, accounting and finance would need the same tool, right? So you want to have an organization where you do both, right? You have some light data and analytics within each silo, and then you have a core dedicated data and analytics unit. And then you kind of have this nice cross section where it's some center of excellence that really focuses on, transparency across the enterprise. Meanwhile, like what's the latest and greatest out of data and analytics, and what are you building, right? So this is what we advocate for. And this is what companies should look for, because you want to understand, because where you see this happen and break really badly is in big companies that end up with duplicate instances of data or siloed data where you don't know what you can cross market or upsell. When you don't know how many accounts somebody holds with your whatever business, or how many products this customer has bought across various pieces of the business, you aren't able to make good predictions because you don't have the whole picture. Right. And that is, you leave a lot of money on the table in that strategy. So I'm a big advocate for this vertical, horizontal, and then cross section structure. And it doesn't necessarily need to be that big. Transparency and collaboration here will really be, reign supreme. Okay. Got about 20 minutes left. I might try to leave some time for questions, but I'm going to kind of talk through what our proposed framework is. This is a work in progress to some extent. This is something that I'll explain where certain things are at in terms of maturity, but I'll kind of talk through what the logic behind it is. And I think most folks will kind of understand what we're getting at here. So this is a really simplified, this isn't the big solve, right? But there's sort of 4 steps in a machine learning process, right? You've got your early data loading, prep, EDA, feature engineering, you've got your model training and assessment. And then typically you jump straight to like deploy model in production. What we propose is that you have a very big step in the middle for a review for explainability, interpretability, fairness. And then every time you fail one piece of that, you jump back into model training, right? You got to do it. And then obviously once you have models in production, there's ongoing monitoring and review. It has to happen. Like you can't put a model live and expect that it's going to continue to perform out of sample consistently over time. These models have to be refreshed. They have to be monitored. You should watch for drift from a data perspective and from a prediction distribution perspective. And then every single step of this, bias, human statistical and data bias can all perpetuate into the models, right? Understand that data loading, bias can exist. Model training, bias can exist. Even in the review for fairness, bias can exist. Just be honest with yourself as practitioners. Like, did you come into this problem with a conclusion and try to prove it out, right? It's typical kind of like critical logic. Do I have confirmation bias here? Or am I trying to prove a conclusion that I entered with, right? So these sort of kind of practices need to be considered very heavily. Now, we published this workflow to MDPI, Responsible Machine Learning Workflow, and it looks as such. Now, what I've done here is I've overlaid what business units hypothetically oversee this, right? So I'm just going to walk through it one time, and I think it'll make sense, right? You've got your you've got your line of business groups creating data in all their various silos or channels. You'll do exploratory data analysis, kind of create some reproducible benchmarks. What are historical averages? You'll figure out some interpretable features that might make sense. you can take a stop and look for fairness, privacy, security, and various pre-processing tools. Then you can kind of look at the universe of causal, constrained, fair, interpretable private models. And you want to try, like, again, my call to action here is, it's really easy to see a new complicated model that came out, temporal neural networks, all of these things. And I would challenge everybody to start simple. Always start simple and see how much signal you can get while keeping the model as white box as possible. Not just because it makes your model more dynamic and stable, but because if you're actually going to be a practitioner data scientist in a company, you've got to be able to explain what's going on. And I think we fall for this attractiveness of hyper complicated models just because it's cool to build complicated things. But it's really cool to be able to explain to a CXO at a company why a model made a decision. So, okay, off my soapbox. Calibrate these models. You do an assessment. You start to do some explanations, model debugging, discrimination and remediation testing, your sort of explainable AI functions. And then here you get sort of to the model risk management, model validation component, where you start to quantify risks. You do model documentation, human review. You might deploy it in production, model management, model monitoring, and then you have a kill switch, right? Like, have certain thresholds you set that determine if this model's acting out of accord, right? And be ready to kill it at any given time. And then human appeal. This is a part of many different AI regulations or oversights that have come out lately. Humans should be able to appeal various decisions that have been made that affect their lives materially based on a predictive model, right? That's not a crazy thought, right? Like if you went out and you're trying to get a mortgage for a home and become a first-time homeowner, you got your first job out of college, you're ready to settle down, or you want to stop renting, you want to start building equity in something. If you get your loan application turned down by an algorithm and they don't explain why, you probably want the ability to be able to appeal. You probably want a human to review it and say, look, these are the features that mattered. We didn't base it on anything unethical. Human appeal is important. And then if, we find that there's areas, look at decommissioning and then doing a root cause analysis. Why might this appeal have come up? Why might this decommissioning have occurred? Why might this kill switch have gone off? And then a sort of call to action across organizations, right? All business groups need to iterate, think about their data quality, their data lineage. And I think at a lot of big companies, I don't know what the audience breakout is here in terms of what y'all do, where y'all work, but at most big companies that have evolved over time in technology expansion and acquisition, many of them have terrible data architecture because they've bought various data warehousing platforms, they've acquired companies, and oftentimes they can't tell you where that data is coming from, or where it originated, and that's critical. So continue to iterate and try to improve your data pipeline, your data quality, your data fairness, and your data collection methodologies, right? So this is the proposed workflow. Now, I don't want to spend too much time here, but I want to kind of highlight some of the roles that we see a lot, and that you should consider having if you have ML as part of your core business or you want it to be, right? In the data science and analytics teams, you'll often have like analysts or BI folks. You'll have pure dedicated data scientists. You'll have some data engineers who are, designing big data pipeline, data quality, ETL, that kind of thing. You'll have MLEs or machine learning engineers that will have kind of a specific flavor of engineering background that is specifically around the kind of like data science technology stacks. This is a newer role. A lot of people are data scientists turned to MLEs or software engineers turned to MLEs. And it's largely evolving, right? Any given day, the technology stack for latest and greatest big data processing and deep learning or machine learning could change, right? And that's good. And that's a good thing. AI ML product manager. This has come up a lot. I mean, typically they're just like a PM, but a lot of times it's really, really useful for these folks to come from a data science background or to come from a stats background, because the questions that you ask about your product change dramatically once you get into the prediction business. right? This isn't some, you know, basic software that just automatically does a rule-based system. And so in sorts, it's you're in the prediction business now. And once you get into the world of probabilistic, not deterministic, it comes with a big amount of questions and considerations that it helps to have a domain expert come in and advise. So from the model validation or internal governance and risk perspective, having a model validation analyst, kind of classic validation, stress testing, analyzing performance, soundness, stability, internal governance, risk and controls. Do you understand the data science supply chain that ultimately creates these models? Is there accountability across it? Do you know who reports to who and who makes what? We forget that this is really important, and accountability is key. You need to know whose feet are going to be held to the fire if one of your algorithms goes rogue and hundreds, if not thousands, if not millions of customers are materially affected by it. And then model monitoring, who's overseeing these models, who's watching them in production. And then typically line of business, you'll have some internal controls and compliance on the line of business side as well. But then just kind of like database administrators or data quality folks to figure out that the data that's being created in the LLB is true to form and accurate. There's some quality checks there as well. And I don't want to spend too much time here, but to think about, I would just press folks to think about what the specific tasks might be around each of these jobs, right? Each of these jobs has different, core functions in their baseline, but like when we talk about responsible AI specifically, what should you be doing to make sure that the process is more stable? And then the kind of reporting architecture, right? Like you have your lines of business, all of your various marketing, digital strategy, ops, accounting, et cetera, kind of feeding data into, providing information and working alongside data and analytics teams who are ultimately going to put together these models, these insights, these outputs, these products, which can then be overseen by the internal governance, risk and compliance teams, model risk management, model validation, model monitoring, and oversee these and check them and make sure that it's sane and the process was stable. And then ultimately like a chief model risk officer, somebody who can really be held accountable to oversee this type of workflow. Okay. Final thoughts. I think that what you want to do with responsible AI is you should push for these following things. And by adopting a responsible AI, practice, process, people, technology, whatever you want to call it, you do a few things, right? You're decreasing risk because you know the risk that you're taking on, because you're increasing transparency. You're preventing technical debt in that you're not building, scotch tape and popsicle stick model frameworks. You're not building things that you're going to have to unwind later the minute regulation comes into play. I'll just stop here one more time and say that if you know how much money banks put into responding to regulatory oversight, and that it's billions, hundreds of millions to get ready for regulations as they come, you should think that there's something very significant that's required to happen under the surface around how your organization is built, how your data is created, collected, organized, and transmitted, and how your models are built, developed, monitored, managed. You should start from a place of best practices now to prevent long-term technical debt the minute somebody comes in and tells you, hey, you probably need to do something different. Gain a deeper understanding of your data, right? There's a good example that I like to say, we used to be able to do analytics on, digital platforms, like your mobile banking accounts. And it's, okay, here are the kind of trends over time. And these are the actions people are making. But what you actually learned with multiple channels or like omni-channel data was this like second order metadata. How much time are people spending on websites? What is their kind of click flow? What is their click through? What are they kind of looking at? What does that mean about products they might have propensity to buy? I think about explainable AI and responsible AI a lot like that, where the more we learn about how our data drifts and how our models drift and how simple versus complex models perform over time gives you this nice like machine learning metadata where you kind of understand this better picture about the texture and distribution of your data, and ultimately what that is, what that means in terms of your customers and your business, right? That's where the deeper understanding comes in. And it's not just why did this model make this prediction, but what does that imply about our business and our customers? And then increase agility and resilience, right? One of the coolest things about statistical learning or machine learning and AI is that you don't have to stop and point in time every period, make a new model, right? When I approached this space, and I don't know if this is a good way to think about it, but I thought of statistical learning as a point in time, or statistical analysis as a point in time analysis of how the data is, but statistical learning or machine learning as an ongoing prediction of how things will be. And I think that by building, stable ML models into the core of your business, it makes you faster to respond to changes in your data because you're not having to do point in time analysis every time. Like you can just refresh the model and reweight and keep going. But it makes you more resilient because you'll just be able to move faster, respond faster, and control risk more effectively. Okay, that's all I've got. I can open it up for questions, Raphael.
But let's take a few minutes and see if there's any questions in the chat. So thanks very much, Ben, for that great first introduction. And we'll have sort of a part 2 of this on Thursday, where Ben's going to go probably a little bit more technical into some of the different techniques that can be used. So I'll open it up for questions. Any questions in the chat? Feel free to.
Yeah, I see one. I think I'm looking in the right place. It says, does HOQ can be configured for explainable AI for business analysts to understand line reason code same as DAI? This is a great question. It's in the works. We're working on that right now. One thing that we're pushing forward is making like XAI more understandable, because we get that it's really complicated. I helped write the book on this as we speak, and I still struggle to explain things sometimes. It's hard. This is gritty stuff, and we are working to kind of figure out what's the appropriate balance to dilute it down so that analysts can understand it, and it's not just solely in the hands of the data scientists to get it right. So I appreciate that question. It's something that we're definitely actively working on. Is there a place to see a consolidated list of all the regs you mentioned? Yes. Let me grab one for you. This isn't a formal list. This is just one that is very top of mind, and I know that it's one of our employees put it together because we think about this a lot. Okay, 1 second. Grabbing it. And it's hard, and it's harder on the reg question too, because things have happened so fast. I started a paper on regulatory themes in February, and I haven't been able to publish it yet because things kept moving too fast and changing too fast that I had to keep going back to the drawing board. If I could make one point clear to everyone here, is when I started at H2O in December, a lot of my conversations were, what will happen if regulatory oversight starts to kick in? And it in the last 7-8 months, it's gone from not an if, but when will it happen to you? Because it's happening now to various companies, and it's not financial services firms all the time. So just something to be aware of, that this is happening fast. A follow-up question to the earlier one about more simplified explanations in Q. It's what is the alternative to this next release? I would say work through the tutorials that we have on how to interpret. So it's pretty easy to build models in driverless. Interpreting it is hard, but we have 2 tutorials public on how to walk through the MLI and the XAI components. And that should give you a pretty simplified version of how to understand some of these things. But I will say we're working on making it more simple, but this is like a nut nobody's cracked yet, because it has a lot of implications about some deeper order maths that we just want to make sure we get right.
Okay, any other questions? So we will have our study group sessions on Saturday and Sunday on this topic. And then our next session will be on Thursday, same time. This will be part 2 or module 2 of responsible AI, or session 2 of module 8 in responsible AI. And so if there's no other questions, we will.
Hey, Terrence, I actually put it in the chat. So it is in the Zoom webinar chat, if you can see there. It's asking about the regulatory list.
Yeah. Let me. I'm gonna copy your link and type the answer to him.
Cool. Yeah, and if you have holdover questions, right? Just give me a shout. Feel free to reach out to me, Twitter H2O or bencox.h2o.ai, benjamin.cox@h2o.ai. Happy to answer anything. And then obviously I'll be here Thursday later this week talking to any questions you think of, I'm happy to answer.
Great. So thank you very much, Ben. And thank you folks for joining, and hope to see you on our next module, our next section. All right. Thank you very much. Have a good day.